All right, today we're going to be factoring by grouping when you have four terms. Some polynomials can be factored into two binomials. Polynomials that cannot be factored, those are called prime. Looking at our example here, 15n cubed minus 24n squared plus 25n minus 40 equals. Now let's take a look here at these. These are two binomials. Okay, two binomials right there. And if we factor 3n squared times 5n, that's 15n cubed, and 3 times negative 8 is minus 24n squared. Go on the bottom. 3 times 5 is, or I'm sorry, 5 times 5 is 25n, and 5 times negative 8 is minus 40. Look at that. We don't have to combine any like terms. Those are all separate right here. So if we have four polynomials, and sometimes they can be factored into two binomials. That's what we're going to be practicing today. Procedure. We're going to factor out any of the greatest common factor. Right? We've done that before in a different video. If you have 5x squared minus 5x, as a binomial, we can take 5x out of that, right? They both have 5x in common. Okay, there's going to be one left over. We can take out the greatest common factor in a lot of scenarios. Group the polynomials into two groups, the first two terms and the last two terms. That'll make a little bit more sense on the example problem. Factor out each group using the greatest common factor, and then factor out the common binomial. This is going to be good for your notes, but I think the example problems are going to be the greatest thing to pull from here. But this procedure should have that written down in your notes in some way, and you can kind of solidify that after a few examples, what's written best for you. I have the procedure down here in the corner. Here we're going to factor 16, a to the third, minus 2a squared, minus 40a plus 5. All right, let's look at our checklist. Factor out the greatest common factor. Okay? 16 to 40, those are even, but 5 is not. Letter A is in the first three terms, but 5. I don't think we have any greatest common factors here, so let's check that off. Now we're going to group the polynomial into two groups. So what that looks like here is going to be 16a cubed minus 2a and negative 40a plus 5. So I have taken the first two terms and I've grouped them. I've taken the last two terms and I've grouped them. Good. Check off number 2. Number 3, factor each group using the greatest common factor. All right, 16 and 2 both even. I think we could take the coefficient of 2 out of there. And the lowest a is a squared. So we'll do that in just a moment. On the right side, it looks like we've got a negative 40a and 5. I think that one's just going to be 5. So 2a squared. What's left in here? 16 divided by 2 is 8a, 1a left over, and negative 2a squared divided by 2a squared is just minus 1. Then here we've got plus 5. Took that from there. Negative 40 divided by 5. Oh, I don't want to do positive there. I want to do negative 5 because the first term that I see, that is negative. So I'm going to keep that consistent. Negative 40 divided by negative 5. I'm just taking that first symbol there is negative, so I want to use that if I can, especially in doing this. That's going to be 8a. 5 divided by negative 5 is negative 1. All right. As you can see, we have done something right here. How do I know that? Because once we've factored out these two things, we've taken the greatest common factor, we have a common binomial, 8a minus 1. Wow, how did that work out so nicely? So we're going to take that common one, 8a minus 1, and I'll leave that there. And what we took out, 2a squared minus 5, that's also going to be inside parentheses, that's a new binomial. We factored out the common binomials. And this is the factored version of what is above. I'm going to prove that to you now. Different color here. 8 times 2 is 16. A times a squared is a to the third minus 40a minus 2a squared plus 5. I rewrote that in a different order. It came out in a different order right here from above, but I think we can say pretty confidently that 16a cubed minus 2a squared minus 40a plus 5 matches up here, so we have done this correctly. Wow, first step of factoring, that's fun. Let's go to another example. All right, 9v, oh, I want my checklist back. There it is. All right, let's factor out what we can. Okay, let's go to our checklist. Number 1, factor out any greatest common factor. 9, 45, 12, 60. Oh, that definitely all has something in common. Do they all share a variable? No, 60 does not have a variable. Well, let's factor out a 3 from everything that we see here. Because 3 goes into all those evenly, leaving us with 3 times v cubed, no change to the variables here, plus 15v squared minus 4v minus 20. It's just like a spot that's not letting me write on it. All right, done that. Let's go to the second one. Group the polynomial into 2 groups here. And also, we cannot forget about this 3 at the end. Let's put like a star, some sort of reminder. We're going to need to include that 3 at the end. All right, we've got the first 2 terms and the last 2 terms. Let's factor each group with the greatest common factor. Okay, working on that. On the left one, I see that they both have variable v, 2, 3, and 15. They have a greatest common factor of 3. On the right side, looks like it's just going to be negative 4. Want to match that first term there. So 3v squared, parentheses, 3v cubed divided by 3v squared. That's just v, and plus 5 minus 4 times negative 4v divided by negative 4 is v, plus negative 20 divided by negative 4 is 5. Look at that, we did it again. We've got a common binomial. Oh, love that. Let's rewrite this. And we've got, remember my star. We've got 3 times 3v squared. Wow, that does not let me write that. Minus 4 times v plus 5. This is the fully factored grouping of this up here. That's a 3v squared, because it should match this. 3 times 3v squared minus 4 times v plus 5. Okay, so this is going to be procedure heavy here. Make sure that you have your notes written in some way. This is how I chose to write it. You might want to use different verbiage. You just got to make sure that you can follow this checklist. Let's do another example. Here we've got multiple variables, and we have an m and an n, an m there, an n there. Okay, factor out the greatest common factor. Does this have a greatest common factor? 35, 56, 25, 45 maybe? Nope, 56. All right, I don't think we have a greatest common factor, so we're good with that. So let's group into 2 groups. 35 times m times n minus 56m. Well, that has got a 7m as a greatest common factor. And 25n minus 40, I think that's just going to be 5. Alright, so let's take 7m here. 35 divided by 7 is 5. Mn divided by m is going to leave us with the letter n. And 56m divided by 7m is just 8. Here we've got, not that, go away. Can't undo that. Go away. That looks bad. Plus 5, because that's positive. And we've got 25n divided by 5, that's going to be 5n. Negative 40 divided by 5 is negative 8. And that's a good sign because that means that our binomials match factor out the greatest common factor. Common binomial, we have one. So our final answer here is going to be 7m plus 5 plus times 5n minus 8. All right. Now we have factored 4-term polynomial by grouping. Good job, everybody. Go ahead and give the try it problem a try, and we'll tackle this in class tomorrow. See you then.